Okay, have you ever stopped to actually think about your daily choices, like what you buy, the articles you click on, or even how you navigate through morning traffic? What if all of those actions are just moves on a massive, completely invisible game board? And here's the really wild part. What if the opponent sitting across the table from you isn't even human, but an incredibly advanced algorithm? Let's dive right into this, because the rules of this invisible game are fundamentally changing as we speak.
Welcome to This Explainer. Today, we're unpacking a massive paradigm shift happening right now at the intersection of game theory and AI. We're going to see exactly how modern predictive algorithms have evolved. They've gone from just passively observing our behavior to actively shaping it. They're acting way less like neutral, objective observers and a whole lot more like digital PR agencies actively tweaking the future to their advantage. All right, Section 1. The rules of play.
So to really get where we're going, we first have to understand the basic rules of play. Classic game theory, that was developed back in the mid-20th century to analyze how rational people make strategic decisions when they have competing goals. It was all about predicting outcomes. And we can actually apply these math models to super high-stakes situations, like the centipede game. Researchers use this to model sequential, pressure cooker decisions in places like emergency rooms. Picture a physician and a nurse. At every single stage, they have a choice. Do they cooperate to maximize patient care, or do they defect early for immediate personal gain? Now, classic game theory assumes people are strictly rational and will just bail out early to protect themselves. But empirical studies show that if you inject a trust function into the math, the whole dynamic shifts. By mathematically modeling trust, we can literally design hospital protocols that nudge teams towards sustained cooperation and way better patient outcomes.
And we see a super similar dynamic over in the financial world. If you map out expected payouts against the probability of winning, traditional game theory applies this same observational logic directly to the stock market. It tracks how traders interact and make their moves. But here's the catch. When you only rely on static, historical data and old-school game theory, the models almost always fail to account for sudden market crashes or the real, messy complexity of human investor psychology.
Moving right along to Section 2. AI joins the match.
This right here is exactly where the game gets a massive upgrade. We aren't just using pen and paper to find mathematical equilibriums anymore. We are injecting machine learning straight into these traditional models. And the crucial takeaway is this transition. Classic game theory was all about predicting the future in a static environment. It just wanted to find a stable state, a Nash equilibrium, where nobody wanted to change their strategy. But AI game theory, it is all about tweaking the future. Modern algorithms recognize that the environment reacts to them. They're actively learning and adapting to entirely dynamic situations in real time.
To put into perspective just how powerful this is, 60%. That is the improvement in the effectiveness of U.S. Coast Guard patrols after they rolled out a game-theoretic predictive analytics algorithm from a company called Armorway. By treating crime prevention like a giant dynamic game of chess, the algorithm literally anticipates where adversaries are going to move next. It significantly outsmarts the bad guys and optimizes where the Coast Guard puts its boats.
Which brings us to Section 3, Shaping the Opponent.
Okay, but what happens when the AI decides that just playing the game isn't enough? What if the absolute best way to win is to secretly steer how your opponent learns the rules in the first place? Just imagine sitting across from someone. You aren't just planning your next move, you're secretly manipulating how their brain adapts to the game. I know, it sounds straight out of a sci-fi movie, but in the world of multi-agent reinforcement learning, this is happening right now.
We call this concept opponent shaping. It was first introduced in a framework called Lola, and it assumes that you can actually control the learning dynamics of the other players. Essentially, the algorithm imagines how its opponent is going to update their strategy. Think of it like playing chess, but instead of just guessing their next move, you are mathematically calculating exactly how they'll adapt to you, and you use that to steer their actions. The AI is literally incentivizing the human, or even another AI, to act a specific way. Let's look at how this plays out in something called advantage alignment. In classic social dilemmas, think of the famous prisoner's dilemma, selfish behavior usually just ruins it for everyone. But with advantage alignment, the AI solves these dilemmas by fundamentally tweaking the game. It modifies its own learning to take the opponent's advantage into account, and by doing this, it steers the entire system towards mutually beneficial outcomes. It's basically hacking the game's incentives so that both players only win when they cooperate.
All right, Section 4, Tweaking the Future.
This brings us to the absolute core of this explainer, where these predictive algorithms really start operating like those digital PR agencies we talked about. This quote from recent research hits the nail on the head.
Algorithms don't just forecast reality anymore, they actively intervene in it. When a platform recommends a product, a viral trend, or a news story, and you react to it, it literally changes the underlying data. The algorithm is creating a self-fulfilling prophecy.
We call this the evolutionary prediction game loop, and it works like this. Step 1, the algorithm makes a prediction. Step 2, the users see that prediction and adapt their behavior. Maybe they post more or invite their friends. Step 3, the algorithm immediately retrains on that brand new behavior. It is a continuous, never-ending campaign. The algorithm is actively running natural selection on its user base, deciding which human behaviors thrive and which ones go extinct. And this leads to a truly mind-blowing, almost paradoxical finding. If an AI algorithm has unlimited data and infinite computing power, what they call idealized learning, it actually destroys diversity. It optimizes perfectly for the majority group, which drives the accuracy for minority groups so low that they just disengage and the groups collapse. It's known as competitive exclusion. But under realistic constraints, where data is finite and computer power is limited, the AI can't perfectly overfit to the majority. That computational imperfection is exactly what allows diverse groups of users to peacefully coexist. Basically, our algorithmic limits are what keep our digital ecosystems diverse.
No way, right?
But hey, we users aren't totally passive in this. Enter prediction intervention games. This is formulated mathematically as a Stackelberg game, a game of leader and follower. The algorithm, the leader, makes a prediction based on data. Then the user, the follower, figures out what the algorithm is looking at and deliberately intervenes to alter those specific variables to game the system for themselves. So it's this constant tug of war between the AI predicting our behavior and us changing our behavior to manipulate the AI right back.
Finally, Section 5, Symbiotic Cyber Defense.
When that follower trying to manipulate the system happens to be a malicious hacker, this game theory suddenly becomes a matter of national security. In modern cyber warfare, static, wall-like defenses are totally useless against adaptive adversaries. So, cybersecurity teams are now deploying foundation models, using these exact game theoretic principles. They set up cyber deception, things like honeypots and digital decoys, to mess with the attacker's perception of the network. They use forecaster-actor-critic pipelines. That is basically an AI that constantly predicts, acts, and grades its own homework to actively shape the battlefield and anticipate the hacker's next move.
The big takeaway here is that simply finding a static, mathematical equilibrium for your defense is completely obsolete. In a world packed with external, unpredictable chaos, systems have to achieve what researchers call decision dominance. It's no longer about building a permanently perfect wall, it's about processing data and adapting faster than your enemy to secure a temporary advantage. Whoever learns and adapts the fastest controls the game entirely.
So, we've journeyed from the mathematical trust models of the ER all the way to the dynamic, opponent-shaping algorithms that are defining cyber warfare and our daily digital lives. We've seen exactly how predictive algorithms act like digital PR agencies, constantly tweaking the future to their own advantage. Which leaves us with one final, absolutely crucial question to ask ourselves. If AI is actively optimizing the game of life around us, are we still the players, or have we just become the game pieces? Honestly, think about that the next time an algorithm suggests exactly what you are already planning to do next.